Hello again. This video we will go over looping iteration in C++, which means to repeat running a process over and over and over. In this case, multiple or a single statement, rather than, for instance, us saying we want to print out "Hello World" 100 times and writing 100 lines that all say "Hello World." We can write only a couple lines that just say, "Take this execution of Hello World, run it 100 times," and we're going to find out exactly how to do that today. In our first exercise, we are going to take a look at for loops. So a for loop is something that you really want to practice so often that it becomes just ingrained in your body exactly how to write it. We're going to write a for loop that computes the sum of the even numbers between 0 and 20,000, and then we'll write some other different loops that do the same thing. So other for loops, but we can calculate this in a couple different ways. So to get started, exercise 1. Here's what we're doing. Okay, so one option of how to do this is to write a loop that says for I equals 0, I less than 20,000, I plus plus. But now let's pause for a second and where did all of this magic sort of come from? And I'm going to break this down one step at a time. When you want to run a block of code, a whole bunch, you're going to surround it in braces, just like we saw with the if statements, but we're going to write the word for first. And this indicates to the computer this is a loop. It's a bunch of code to be executed multiple times in succession. In parentheses here are 3 parts, and I've actually messed up already. This should be a semicolon. The first part here is the initialization. So this is a line of code that is run, a statement that is run a single time before the loop ever runs at all. And in this case, we're saying make an integer I standing for iterator, and start at 0. The second is our condition. This is a check to see every time the loop goes, do we keep going or not? And in fact, actually, I messed this up as well because it says 20,000 inclusive, so I need to include equals. So as long as I is less than or equal to 20,000, we're going to keep doing the thing. And this last part is what happens after the loop reaches the end, which means every time that we go through this little cycle, once we hit the bottom, we say, okay, what do we do next? We increase I by 1. So I plus 1 is a short form for I equals I plus 1. They mean the same thing, but you usually just see I plus plus because it's faster. And what this means is I now have a loop that is going to give me a whole bunch of i's. In fact, it's going to give me all of them from 0 to 20,000. So if I say printf %d new line I, it's going to print me all the numbers from 0 to 20,000, all the way to the bottom there. But I'm not here to print out numbers 0 to 20,000. I'm here to compute the sum of the even numbers that are here. So how can we do that? Well, first of all, we need to store the sum somewhere. So we're going to make an integer called sum. I'm going to start at 0. I'm going to keep adding to it. And we add to it if I is even. Now, how do I know if I is even? I know if a number is even if I can divide it by 2 and have no remainder. So there is a operator for this, and it's called modulo. So if I take I and divide it by 2, and the remainder is 0, then it is even. But I'm not dividing, I'm figuring out the remainder after division, and that is the percent sign, actually. So when you use a percent sign, this means modulo, and it means do the division, but instead of giving the quotient, which is the result of the division, give the remainder. And if the remainder is 0, that means it's an even number. And if it's an even number, I want to add that to my sum. So sum equals sum plus I. And let's see what we get. Well, if we did this correctly, we get, what is that? 1, 2, 3, 4, 5, 6, 100,010,000, which turns out is the answer that we're looking for. Now let's write 2 other loops that do the same thing. There's a couple changes that we can make. There's many ways to do this, but let's do it one way that means we don't have to figure out the modulo thing. And it's actually pretty simple. Same idea here, except instead of going up by 1 every time, why don't we just go up by 2? That way we don't have to worry about the even numbers because we're always going to have even numbers because I is only ever going to be going up by 2, 0, 2, 4, so on and so forth. And we'll see if I do that, it's the exact same answer. Now we also can do it backwards. So let's say that we once again take this, but instead of starting from 0, we start from 20,000. We go until I, as long as I is greater than or equal to 0. Instead of going up by 2 every time, we go down by 2 every time. We get the exact same answer every time. So 3 different loops. They're not the same for sure, but they all operate to solve the same problem. And that's sort of a good lesson for computer science and for programming, which is that almost always there's more than one way to solve a problem. So let's take a look at another one. Our next problem is a while loop. So write a program that initializes a large number x and a small number y and uses a while loop to figure out the largest number smaller than x divisible by y. Okay, so a lot going on in here. So once again, we're going to want to break this down into just subparts until we can solve exactly what we're looking at. Throw in the question, exercise 2, and let's think about this for a sec. Okay, one step at a time. Initialize a large number x and a small number y. Okay, so x is 10,000. Y is 3. That's a pretty small number. Use a while loop to find the biggest number smaller than x divisible by y. Well, I can probably guess it's just going to be 9,999 because that's all 9s, and I think 3 will go into that. I could be wrong, though. I guess we'll take a look and see. So let's say that I go with, well, actually, no, I know that's right because I can just multiply by 3,333. So our answer should be 9,999, but let's make sure that that's going to work. Use a while loop to find the largest number smaller than x is divisible by y. So we're looking for an answer. So int answer is 10,000. So this is the biggest number that we possibly can have, while our answer is greater than 0. We're going to reduce our answer by 1, and then we're going to check and see, is this divisible by y? And if so, that's as big as we can get. That is divisible by y, and then we're finished. So if, and now how do I know if the answer is divisible by y? I use the modulo again. So if answer modulo y is 0, that means it's divisible. And now what I can do here is I can use a command called break. And break means to exit a loop, to just get out of it. I am done. And if I've exited the loop, that means that my answer is the largest number smaller than x divisible by y, which, as I thought, was all the 9s. Now let's say I try a different number, say 11. I don't actually know what the largest number smaller than 10,000 divisible by 11 is. Actually, it's probably the same thing, isn't it? Yeah, okay, let's try something different. Let's try a 7. There we go, 9996. And it turns out 9996 divided by 7 is exactly 1,428. So that means that 1,428 times 7 gives me 9996, which is the largest number smaller than x divisible by y, which is what I'm looking for. And I can't use a for loop for this because I don't know what the answer is going to be. I don't know how many times this loop is going to go. But in this case, it went until, basically went about 4 times. And once it did, then we exited the loop, and now we are done. Okay, on to the next one. Okay. Now, for loops are while loops. So in our first program, we used for loops. And now let's make a while loop that solves the same problem of computing the sum of those numbers. And it turns out actually being able to do this isn't too complicated at all. So let's duplicate our first book. This is going to be exercise number 3. And here we just want to, and we can get rid of the other ones that we did. Just want that first one. Make a while loop that solves the same problem of computing the sum of even numbers below or up to 20,000. It's in word wrap again, even though I fixed the setting. Okay, well, that's fine. So let's try this out. And what we want to do is we want to turn this into a while loop. So to turn this into a while loop, remember, all we have to have left in a while loop is a condition. We need to have when are we going to stop? In this case, we said we were going to stop as long as the answer was a positive number because we wanted to, eventually stop at some point. And as long as our answer is going down, eventually this will finish. But I really could have written while true in here, and this would be fine as well. Wouldn't be good because there's a chance that this would mess up. But inside of these parentheses are the condition that must be true for the loop to keep going. And so here, well, what's the condition? The condition is actually this part here, the I less than or equal to 20,000. The first thing that happened in the for loop, this I equals 0, we're just going to put it outside the while loop, and it's going to happen before the loop runs. Similarly, this last part here where I goes up, we can get rid of that and put that at the bottom of our loop in the form of I++. These are the same thing. And I basically made it do the exact same thing, just now I'm using a while loop instead of a for loop. So ultimately, every for loop can be converted into a while loop if you know how to take the pieces out and put them into different spots in the program. Okay, we're now on to the last one. So exercise number 4 is a do while loop. Write a do while loop that halves an integer and prints out the value until the number reaches 0. So last but not least is exercise 4. An integer is going to be my number, which will start out at, say, 1,000. And we're going to say do braces, and after is while my number is greater than 0. And once it is 0, we will exit the loop and stop. So have the integer. Okay, so my number is my number divided by 2. Another way you can write this is my number divided by equals 2. Same thing. Print its value, okay? So we'll do print the number with a new line character after it to space it out. And it's my number. And that's it. So 1,000 gets halved to 500, halved to 250, halved to 125, and so on. And you see we're doing integer division, so eventually it does reach 0. And then we stop. So you'll note that the difference between a do while loop and a while loop is that if I decided my, my number was 0 to begin with, I would still do it once. Because this part of the code happens even if this condition is false at the beginning. We don't check to see if we exit the loop until we've run all the code in here and then verify to see if we're finished or if we have more to do. All right, so that's it for loops. I definitely recommend practicing lots of exercises with loops, with branching, with data types. These are really the core pieces of what it is to code, not just in C++, but in basically every sequential coding language. So get lots of practice, and I'll see you next time.